So hello everybody. I'm Sam Vanhoutte. I flew in from Belgium, and I'm CTO at the company Codit. So one slide about us, nothing more. So we are based in Europe, 7 countries. Not yet in Scandinavia, but we are really looking to approach this as well. So if you would be interested in starting your own company, don't hesitate to ask me. But we are focusing on 4 core domains, and that's integration, so connecting applications, connecting systems. It's API management, so I think the last session of today is all about API management. It's Azure solutions, so architecture, the whole things with event sourcing, distributed applications, and that's why I'm talking here, the IoT space. So we did quite a lot of things in the IoT world, and we only use Microsoft technologies, okay? So this is a very high-level picture of how the IoT landscape and how an IoT value chain, if you want, is typically built. So what you always see, of course, it's all about the things, the devices, and these can be a lot of things. We focus mostly on bigger things like machines in factories and so on. We are not necessarily in the consumer market where customers will have the next nice gadget to have a smart toast and so on. We focus mostly on industry, transport, and things like that. The thing is that if you have devices in the field, you of course, you do IoT because you want to be there. You want to be on this right side. That's where you make your value. That's where you do big data, analytics, all these things. That's where you start automating stuff, where you do integration and all these items. So of course, this is where the cloud would start, where you have all your interesting services with Azure, and I'll dive a little bit deeper later on. But the most part of this talk will be about the left side, about getting data from in the field, from your devices, into the cloud. Because if there's one thing that I've seen in the past years with IoT is that this is hard. This is something that customers a lot of times underestimate, the complexity, and actually this is like a necessary evil. You just have to be able to get your data in the cloud, but just getting it there is not adding value. The value is there. That's where you build the nice projects, the nice integrations and all of that. And that's why the edge, which is the main topic of this talk, is really a core capability that is becoming more and more important. So I was in Barcelona early this week with the IoT solutions fair on the Microsoft booth, and I think the pod where the IoT Edge team got most of the questions and most of the audience, because everyone knows that, especially in the industry, that is really where the things are happening now. And I'll talk a lot about that. Now, it's all about connecting, as I said, and connecting devices typically happens in 3 different ways. The first thing is you have the direct connectivity, where you have a device, and most of the gadgets that you have at home, they are like a direct connectivity. You have a device, and in the device there is some software with some network connectivity that connects directly into the cloud. That's of course much easier to sell, to install, and all of that. But of course, it also means that you have your logic of internet connectivity on the device and mixed with your device logic itself. So in the industry, for example, what we see is that a lot of customers who make machines in I don't know, food processing and things, they don't want to have the internet connectivity mixed with their production logic. So typically you want to separate that. And if I go back to the previous one, that's why they say, okay, the product logic is there, and this is where we do the connectivity. And we really make a separation. Most of these devices in the industry are not direct connected. So this is more for the consumer things. What we also see is that you have cloud gateways. So cloud gateways is typically common in things like Sigfox, LoRa, narrowband IoT. What is that? That actually means that you have devices that have a chip. That could be like a cellular SIM type of data. It could be radio type of data. And these devices are typically autonomous. So they have a very long-lasting battery They don't need any Wi-Fi, any real network connectivity, because it's all embedded. Typically, they also have very low frequency of sending data, so you will not use it to stream media. You typically send it for alarms and so on. So one of these samples that we typically have is trackers. So we have a customer who wanted to track his containers of waste, because they want to do recycling. And there's like a black circuit where your fridge that has to be recycled suddenly would end up as a second-hand fridge that gets rebuilt in Africa, for example. And that's not the intention. So just by plugging one of those cheap sensors that is like a GPS thing, allows them to track where that is going. So that means it's connecting everywhere, because there's like no roaming for them, and it has a very long-lasting battery life. So that's where you see these cloud gateways. What I mean with that is these devices have their own backend. For example, Sigfox has its own backend. If you have a narrowband IoT, you need to talk with your telecom provider, and they will have their own backend. And if you then start building the solution with your data analytics, you typically have not to talk with the device, but you talk with the cloud gateway with the backend of that telco provider. So that's a very common scenario in smart cities and so on. So if you have smart parking sensors, if you have things like to measure the wastes in waste bins, tracking of lights and so on in the street, that's very common to have that type of connectivity. But the most common things in the industry is on the right side. That's the field gateways, because you have a lot of devices that have their data available, but you want to have something attached to that. You don't want to change machines that maybe are running for 20 years. You don't want to change that and suddenly ask to your device programmer to add internet connectivity in that device, because it's hard and it's not always secure, or you want to separate that process logic for your core from the internet connectivity. So field gateways is a very common way of connecting devices to the cloud in the more industrial scenarios. Now, what we have seen, because everyone knows that if you're doing IoT today, a lot of these projects are first pilot, proof of concept. What we see is that, of course, in the proof of concept, you focus on the value creation. You want to be showing something quick, show the concept, learn about these basic things. So you use simulated devices or very simple devices. It's all about just get it connected. We will find about it later on and so on. And you focus on the right side, on the value creation, on the reporting and all of that. What we see, however, if you then move from your pilot all the way to production, things become much harder, because that device that you used in the pilot, it could be your Raspberry Pi and all these, hobby devices. Once you move that into production, you have to think about so much more things. You have to think about the fact that actually once you have your device deployed into a factory, into the field, into your streets, whatever, that once you do that, you can no longer touch that device. So you have to think about all these complexities with retries, with what if the internet fails, I have to buffer maybe some data, all that complexity. What with security? What if you have your device and it's using some security mechanism, and suddenly you know that, I don't know, NSA or something announces, and the security algorithm that you've used last year is cracked in 2 years, for example, you want to have those devices updated. If you have to do that, that's freaking hard. That's really hard to update devices that you no longer connect to through remote desktop and so on. So one of the quotes that I learned from the Sam George, which is the product manager at Microsoft for IoT, was software is fast. So on the right side in the cloud, you can very easily iterate. You can change your business logic, add value, like just by using your continuous integration pipelines. And I think Carlo will talk about that. But things are slow. Things are slow. Once you have your things deployed, that's where you have to think about. And that's the hard thing. That's where we really see these things. And if you see what we spent the time on in proof of concepts, it's really about analyze and then the business value, where the connectivity part becomes much more bigger in the amount of time you spend. And customers don't want that. Customers don't want to spend all that time and all that money in the whole connectivity, but they have to because it's so hard. But it doesn't add them a lot of value. So I think Microsoft is trying to make that more and more and more of a commodity. that whole connectivity thing. And that's why they are focusing on the edge. Now, one of the things that we have seen as well is that there's, I think IDC has one of those studies, 85% of the devices that is out there is not having any internet connectivity at all. And if you're looking at things that you have deployed in the field, maybe that projector there has some local interface that you can talk to. It could be a Bluetooth, it could be Zigbee, it could be something SNMP, whatever. But if you would be able to connect to that device, you can just start monitoring that device in an Internet of Things scenario as well, without having to change that device, without having to do an update on that device specifically. So if you have an existing install base and you focus on that one, you really can work on what we call the retrofitting challenge, where you have existing devices and you connect them to the cloud instead of just focusing on the new generation of your devices. And especially in the industry, that's very common, where customers that deploy machines into the field are really focusing on this. They say, okay, we have all those machines for years. Let's just focus on getting the data that is there locally. Let's focus on collecting that data centrally across all the customers. And that's what we see with the field gateways. Now, that was more on the concept. Now I'll talk a little bit about the Azure services, of course, because this is the Azure conference. So what Microsoft provides in the Azure IoT landscape, and I'm going from the high level all the way to the core, is of course some out-of-the-box things, like SaaS products. So they announced Microsoft IoT Central, and that could be like the Dynamics or the SharePoint or the Office 365 for IoT. That also means it will be pretty basic, especially in the first versions, but it allows you to just connect devices and to have your end users even define some data models and monitor, in pretty basic reports, all those devices. So you have device management and device monitoring in IoT Central. I think the public preview is announced for later this year. So this is still in a private preview phase. So you cannot see that yet. But IoT Central is something that was announced as a real software as a service for IoT. They also have connected field services, which is linked with Dynamic CRM, and I'm not going to talk too much about that one. What they also have is the IoT Suite. IoT Suite is something that you probably have heard about before. If you've ever looked at IoT Suite and the remote monitoring, you know that you install it and you look at it and you throw it away because it's not really interesting to work with. It's pretty hard to extend and it doesn't have a nice user interface. Now, they are changing that and I think later this month they will announce the new pre-configured solution for remote monitoring, and I've seen that, and that sounds 10 times better. But what it is, they have solutions in some verticals, like remote monitoring means you monitor devices in the field, you see their telemetry and so on. You have predictive maintenance, which gives you a good example of how you predict things, and I think they are using an engine of an airplane. And they have the connected factory, so for the industrial IoT. Things like OPC-UA and so on are very common in that scenario. So they are pre-configured solutions. So you just have an ARM template. You can deploy it from GitHub or through the website to your own subscription. It uses all the Microsoft services that are needed for that. And it's open source. So if you ever have to do a nice proof of concept or something, it's definitely worth looking at those pre-configured solutions because you get a lot of value for free. And maybe you need to focus on the specific things. And you can just customize. So in the past that was pretty hard with the remote monitoring, but the new one that I've seen at least sounds much more promising. And actually it will also be based on a microservices architecture using containers. So the session from Elton just before was pretty good in this concept because the Docker concepts with containers is coming back in IoT. Both on the server side, where you have the microservices architecture, and also in the edge, which I'll be talking about in a few minutes. The good thing is that all of those services are built on the PaaS, on the platform services of Microsoft Azure. So what you have, of course, is that it all starts, and that's where you have the entry point for IoT, where you have Azure IoT Hub, and which is now in public preview, the device provisioning services. So that's where you have the entry point into the cloud. So devices will be sending to IoT Hub, and you can also send commands from the cloud services all the way back to the devices. That's IoT Hub. It scales to millions of devices that you can connect to one hub and so on. It's deployable in all the data centers of Microsoft. And to know that a device has to be connected in a certain data center, you have now the device provisioning service. So what is it used for? If you, for example, have a car, you're building an automated car or a connected car, that car has to be like activated once it's used somewhere. You want to know, or you want to have it activated close to the region where it's used. So if you're buying a car and you're using it in Switzerland and you do the setup, that car could connect to the device provisioning service that it knows. It's like the call home address. And there it can send basic things like maybe the location, like this is my current location. And this service allows you to say, okay, that's a car coming from Sweden, so let's now provision it in the, I don't know, Northern Europe data center on that IoT hub and so on. So that's a nice service that was added recently, the device provisioning service. So that's where you have the link between the field and the cloud. Then you have these things to build devices. So you can do the Azure IoT SDK, you have Windows IoT Core. Of course, you don't have to use that. IoT Core is getting more and more popular, but most of the current devices that we see in the field are Linux-based or Yocto and things like that, or embedded software. And for that, you also have SDK things on C and so on. And you have some security programs on the left side. And then once you have your data in the cloud, you can do all this magic with data analytics. So Microsoft is really, really adding a lot of value for stream analytics, for example, which is, and I think you talked about it yesterday, Alan. Yeah. So which helps in, let's say, the hot path analytics. But of course, you also have the open source stacks like Spark, Hadoop, Kafka, and so on. One of the services that was added as well is the time series insights. And I think it G8 or will GA soon. But with time series, you have, I think 90+% of all the data that is collected in IoT is time series based. You have like a trend that you want to see. It's always, you have measurements based, and you always have a timestamp. With time series insights, it's pretty nice to just see real-time information, real-time heat maps and so on, and you can drill down, and you don't have to, this is all based on a schema-less design. So if you have data coming in, Azure Time Series just accepts all the data and gives you very interesting insights for that. Then of course you have event hubs, machine learning and so on. I think we had a session this morning on that. Cosmos DB, all these things for your data side. On the right side, that's where you do the real connectivity with everything. You have Flow, you have logic apps, and of course you have all the monitoring services. So I won't dive too much in those things. The most important thing for this talk is the IoT Edge. So IoT Edge was announced, I think the first time at Build. I think that was April or something this year. And it was announced there, and it's still in a private preview. So I was hoping by the time I submitted for this session, and I think that was maybe in July or something, I was hoping to be able to present it today, but it's still in a private preview, so I'm not allowed to show the current version of the IoT Edge. But I can talk about the concepts, and you will see, you will understand how everything works. But before I talk about the details of Azure IoT Edge, I think it's important that we all understand on Azure IoT Hub, because that's still the core service that will link with the Edge, and how you do device management there. Okay? So on the left side you have the Edge, on the right side you have the cloud backend, and in the middle typically you have IoT Hub. So IoT Hub has, of course, it's like an event hub where you have all the data coming in, but it's an event hub in a bi-directional way where you can also send commands back into the field. So if you have your physical device here on the left, what we see is that on IoT Hub you can create like a digital representation of that physical device in the field, and that's what we call a device twin. So that's like the software version of your physical device. And on that twin, you can add some tags, which is just the metadata that you can define for yourself. You can say, oh, it's Microsoft, it's Sweden, it's Stockholm, it's, I don't know, Windows. So just the tags that you want, because these tags you can use later on to schedule jobs, because in a proof of concept, you focus on one device till 10 devices maybe. In reality, a lot of customers target more than thousands of devices. And then you want to have the capability of updating devices, of managing devices on a more bigger level than just that one device from the proof of concept. And for that, the tags can be very interesting, because then you can say, I will update the firmware of all the machines that have maybe a tag that is version 1.6, something like that. You also have properties. So properties, you have it in two ways. You actually have the desired properties and the reported properties. So the desired properties are actually written on the cloud side. So for example, if the AC, the air conditioning system here, has a desired property of 22 degrees Celsius, that's something you would set on the right side. You said, I want it to be 22. And then this can be reported all the way back to the physical device using the standards that IoT Hub has. So then the device knows, oh, my current temperature is, I don't know, 20, and that has to be 22, the desired property. So it will make sure that it takes the right action. And it will also report back what is the actual property. So this can also be used for firmware, for example, where I'm saying that the desired version of my software firmware is the 1.2, but the reported version is still the 1.1. So I can write a job later on, and I can say, give me all the devices in my field that have a version, an actual reported version that is different from the desired version. Oh, I have 10 devices. Actually, that's a device, or that's a list of devices that I have to take some action, because I want them to be upgraded, and actually they didn't do the upgrade. So I have to monitor on that. That's where you have these nice, interesting concepts. And then, of course, the thing that is known the most is the telemetry, where you have devices sending their temperatures, there's a vibration, whatever you want to monitor. They're sending all that telemetry into the endpoints of IoT Hub. So you have different protocols that are based on standards. It's AMQP, and AMQP can be used over TCP. Then you need a little bit more on outgoing firewall ports. So it's not just over the standard ports, but you can force AMQP also to run over WebSockets. And that's interesting, because then you just use the standard HTTP ports, and then you still have the sessions of AMQP, because a device keeps connected and it doesn't have to do the polling. So that's an interesting concept for AMQP. But you, of course, also have the MQTT, because Microsoft knows that that is still probably 10 times more asked than the AMQP thing that Microsoft pushed in the initial things. If needed, you can always fall back on HTTP, but then you do the long poll, where you have like every X time you do a request and you see if there's data and so on. So if you can, always use AMQP or MQTT, because then you're having much more sessions and much more or much lower latency. So the device metadata, I think I talked about that quite a bit. So you can set your metadata on the properties, and you have the tags. So the tags is just for your metadata, and then you can do queries. You can say, give me all the devices in my system that have, I don't know, a Windows system, or give me all the ones that have a Linux system, just based on the properties. I will show that in a demo later on. And you can schedule jobs. So I think I talked about that, but I can create a job that says update all or execute that method on all the devices. For example, turn it off on all the devices in time zone Japan, because now they are out of business hours, for example, in the movie theater. So shut down all the machines, because we want to save energy. And you can do that based on tags. So one of the things we often use in the tags is, for example, a time zone, because there you can also schedule updates, and you do the updates typically outside of the business hours. And if you use a time zone in a tag, you can use that, for example, to set things. But you're really open to do whatever you want there. So queries and job are pretty important. the desired properties I talked about and the report properties. So what I will do now is quickly show how the IoT Hub works, how you can use it from a developer point of view, and after that I will switch to the IoT Edge, okay? So I won't spend too much time in this thing, but this is, of course, the portal that we have, where you have an IoT Hub. You can create it with a few mouse clicks, and on IoT Hub you can set quite a few properties, the scalability and so on. But of course you have the most important thing is the, and I can zoom in a little bit, is your devices. So you have a device explorer and you can create new devices. Of course I only have 4 devices in this case. This is just my test IoT Hub. But as you can see, you can execute a query. So you can execute a query to filter on devices, and you can use those metadata tags and so on. So what I frequently use actually is still the device explorer twin. But what Brady showed yesterday sounds interesting as well, where he had a tool that he could use in code to, for example, filter on things there. So to connect to an IoT Hub, you need security credentials, so you can just get them from the shared access policies. It's like a connection string, and you enter that connection string in this tool, for example, and there you can see all the devices that you have installed. And then on a specific device, you can set all the metadata. So what I will do here, I will just start this thing again. So this is an example, and I'm happy to share it. I think it's even on GitHub. An example that does all these IoT Hub specific things. It uses WPF because that's what I do. I'm not a front-end guy, so that's the best I could do. But what you have there is different tabs where you have all the concepts of IoT Hub. So the first thing, for example, is the telemetry. That's the most common thing. In the proof of concepts, what we do, we collect telemetry, we send it all the way into IoT Hub, you do some stream analytics, and you save that, for example, in a Power BI data set. So what I will do on the right side here, on this thing, I'm setting up a new thread actually, that is the server side. So he's listening for data that is coming in from my devices. And he's listening on the server side telemetry endpoint. And for that, he's using the exact same thing as you would listen on Event Hub. So people that have seen Event Hub in the past, this is the exact same way of reading there. So you have a few partitions where the data comes in, and you just connect on that. On the left side here, I have some, this is my device that I will simulate, where I can send some metadata in the message, and I can send the message itself. So a message for IoT Hub is can be anything you want. So it does not have to be JSON. We see, especially in demos and proof of concepts, it's JSON mostly, because that's where the easiest things are. In reality, we often see that you send byte payloads to get the data very small and so on. But you have that, and you can send metadata with it. So like with Service Bus as well, you have a context where you can set some metadata. And that metadata can be used to filter in the cloud, and I will show that shortly after. So I will just send my message on the left side, and you will see on the right side, you should see like there that the data has been received on the server. So this is pretty simple, but of course this scales to millions of devices, and every device has its own identity. That's also pretty easy, pretty important. If you have thousands of devices, it's very easy to say, okay, device 15, I will disable it because it got hacked, it's behaving crazy or something. So you just disable that device, and that device is no longer having the ability to send into your IoT Hub, but you don't touch anything else. So that's pretty important there. What I wanted to show as well, and let's zoom out, is the concept of routes that was added, I think, about a year ago. So this is my IoT Hub, and on IoT Hub I can set, first of all, I can set endpoints. So you create an endpoint, and then you can say, I will route it to Event Hub, to a service bus queue, to a service bus topic, and also, I think this got added a few weeks ago, to storage. So you can have your data coming in, and automatically pushed all the telemetry data, for example, to a storage container, without having to write any code. So before, in all the proof of concepts that we did, we were using stream analytics, and that was costing quite a bit. Now, with IoT Hub, it's all out of the box. So you just have IoT Hub, you have a storage container, you set up this route, and you don't add, it's just the cost of your telemetry. So that's pretty interesting. And honestly, I think, I don't understand why they are not asking more money for this, because this is like out of the box. But is this recorded? So you just set up your endpoint, for example, service bus queue, you specify a service bus namespace, and so on. I think I have topics. Yeah, this probably has to be refreshed, but you get the point. You can set up your endpoint here. And what you can do as well is create a route. And this is where you do the routing, where you have the incoming messages, and there you will say, okay, messages coming in from there, I will send them now to that storage container. So here you create a new route, and in a route you can specify, of course, the name. You can specify and I will zoom in again, the source. So device messages is the one that I talked about with all the telemetry coming in. At the same point, you can say if my twin, so the digital twin that I talked about, if there's a property that got changed, I will send that event as well to, for example, a service bus topic. And that could be interesting to have you doing some filtering, where you have your microservices or whatever polling on those topics and subscriptions. And you can say, okay, I will listen to those specific change events. And it's the same thing with the lifecycle events, where it gets enabled, disabled, and so on. I don't know how many people have heard about Event Grid, but Event Grid is a service that got announced maybe 1 month ago. I was on holidays. That's long ago. I think it was in August. And that service sounds very interesting, and actually it conflicts a little bit with it. Like, if Event Grid would have been there, I'm not sure if they would have used this concept of routes. So what Event Grid is doing, Event Grid is a service that is very, very highly scalable inside Microsoft. And customers like us can use events, let's say publishing, from all the services in Microsoft. At this point, it's mostly storage. So you can say, if a new blob gets created in this container, publish an event to, for example, this webhook. It's like an endpoint you create, and you have some logic you do. So you don't have to do all that polling. You just open up your endpoint, and it gets pushed to you. So this could be interesting as well, because IoT Hub is probably also looking if a device disconnects, so it suddenly loses its connection. At this point, we do this. We have to write polling, and we use the actors that we heard about yesterday from Service Fabric. We use actors for every device that is checking if the device is still connected, but you don't want to do that. You don't want to ask every single time. It's much more easier if Event Grid just pushes to me and says, hey, there's a device disconnected, because then you have to use, you can use much less compute power, because polling is expensive. So Event Grid might be an alternative to these routes, if you ask me. But getting back here, I can say, okay, all the messages from that device, I will send them to this specific endpoint. And you can set up a specific query string. So I can show the things there, but you can there filter. You can say, okay, all the messages with property of, I don't know, type is temperature will be sent to that queue. All the messages with a type that says my device is disconnected, for example, I will send to another queue. So you can do some basic routing, and you have a lot of application and routing logic separated away from your processing. So the things that we heard yesterday with the event sourcing and all of that, this makes it pretty easy here, because you have out of the box the events that you can publish to your queue. And from there you have all the microservices that just can process their specific event. They don't have to do all the rest. So that's the thing I wanted to talk for the IoT routes. The next thing I wanted to show, but I will skip this one, is file upload, just talking about it. But you also have a file upload thing, because IoT Hub messages are limited to, I think, 256K, or 512, one of those. But at least they are limited. Sometimes you want to upload larger things, like maybe you're sending data into the cloud, but if someone approaches, you want to take a picture of that person and send it in the cloud. You can still use IoT Hub, but you will not send it as a telemetry message. You will do a file upload. So you upload the file, and it will store it into a blob container, and it will send an event over the IoT Hub. So your application is still using the events stream, but it gets like, it's like a claim check pattern. So it gets a reference to the blob where it can handle all these things. So what I will do now, I will create some sample devices first. So I'm creating devices, some lights and so on, with some metadata. So if I now go here and I load my devices, you will see that I have these lights created, for example. And if I click on the light 4, this is my specific, this is the device twin. So here I have some tags, and a tag is not just a name value pair, it has some hierarchy of structure. So for example, it says location, and it has a building and a floor, right? So I'm able to write a query that says, give me all the devices where location.building equals Codit, or where location.building equals Microsoft, and floor equals 3. So using that type of construction is pretty interesting. And of course you can update those things there. And that's here. So what I'm doing here, and I hope you can still see this, but this is, for example, tags.location.building equals Codit, but I'm changing it to Microsoft, for example. And what I'm saying here is that for all the devices that are based in a Microsoft building, I will set the temperature now to 30 instead of the other one. So by executing this query, it launches a job. It's asynchronous. The IoT Hub has like some orchestration. It launches the job. You see, I'm now polling for the job, and it runs, and in the end it's completed. So IoT Hub takes care of, let's say, updating these devices in an asynchronous manner. So this could be thousands of devices. So I'm not having to do the 4 each and all of that. This is just scheduling one job, and IoT Hub is doing that. So if I would go back to the device metadata and update this thing again, this, for example, was Microsoft device, so I'm hoping to see the temperature. As you can see, the desired temperature property now got updated to 30. Okay, so that's a very interesting concept as well. Now, that was the IoT Hub part. I'm now switching to the IoT Edge, because that's where you have the core of this talk about. So what we see is that the edge capabilities are becoming more and more important in IoT. For example, we have a customer that we are, setting up the architecture now, and they are in the mining industry. So I think it's gold mining, so it's an interesting business. But that's typically, it's not in a place where you have easy connectivity. You have very, like satellite connectivity, it's very expensive and all of that. But still they want to have very, real-time monitoring, because they will have self-driving trucks going to these mines and, drop all these things. So what they are doing there, they will use edge capabilities where all the local things get monitored. So all the trucks are sending their data into a local compute power. So that might be a server in the factory. They will do some real-time reporting and all of that using the edge. And they will just stream, let's say, the aggregated events, the real important events, they will stream that all the way into the cloud. And Azure IoT Edge can help them, because if, for example, the connectivity is broken for a few minutes, Azure IoT Edge will just take care of the buffering and will send it once the connectivity comes up again. So that's one of those scenarios where Edge is pretty important. So what we see is, of course, that's the typical pattern where you have the things, and until now we did everything in the cloud. What we see is that more and more some insights and some actions are moved into the edge. So one of our customers said, if my machine A in the production line starts to do something above a threshold, like the temperature gets too high, I want to take immediate action and disable or send a command to the other device that it has to stop, for example. Devices are not sending to each other because they are, let's say, decoupled. So the edge wants to take, they want to take those actions locally, and they don't want to depend on the internet. If you would have your self-driving car in a few years, you don't want to have your cloud connectivity to decide if you can hit an object or not with your car, right? So if you need to choose between one of those things, that's all logic that you want to execute locally. So what Edge is doing, they are moving some things from the cloud capabilities, to the local compute, both for data processing and for, let's say, intelligence. So we will talk about some of those services that they are moving on the Microsoft side. So of course it's all about low latency execution. So Azure IoT Edge is cloud managed. That's also important. If you have thousands of factories and you have all of them have an edge compute system, you want to manage them from a central place. You don't want to do a remote desktop to update things and so on. So Azure IoT Edge will have a cloud native management. So you will be able to update that specific gateway or that specific edge device from the cloud through software on Iot Hub, and all the rest gets handled locally. It's cross-platform, so it uses Docker under the hood, and that runs both on your Windows systems as on the Linux systems. And of course it's extensible, because Microsoft really knows that in IoT they cannot provide everything. So you have to be able to inject your own custom business logic on that edge yourself. The intention is that Azure IoT Edge can run on small devices, not on the, let's say, the sensor and the very tiny devices, but as from, I think it was 128 megabyte, that was like the target where they are aiming at. If you have a device of that level, Edge should be able to run. So as I said, it uses Docker to schedule all those services, and that's the target. So that's pretty, let's say, small devices if you want. And this is the only architecture slide that is publicly available, but it gives a good overview and a good insight on the architecture. So this is what I am running in the field, not in the cloud. This is my cloud thing. So that's still Iot Hub, and Iot Hub has the device twin that I talked about, but it will get an extra concept of module twins. So I showed the device with the twin. So the twin was all the metadata, the tags and all these things. We will see something appearing probably that has a module twin. So I'm able to say what a module looks like, because all of these things are modules. So this is the edge, and if you would install the edge, once it's available, you will get some local execution thing. They are planning to have Azure Functions, and I don't think we have a talk on functions this conference, but functions is like serverless execution of small pieces of business logic. That functions runtime will have the same thing, and it will be running locally. So you will be able to run it on your development machine, but also in the edge. It has some local storage, and it has, of course, the device twin. And then the most important thing, it has container management. So that's actually the Docker runtime with some automated commands that get executed. And once your edge device starts up, it will ask to the Iot Hub, like, give me the configuration. Iot Hub will say, hey, that's it. You have to spin up these different types of modules, and actually each module will be a Docker container that is spin up. So you the image from that Docker container will be coming from a repository in the cloud, probably. I'm not sure if that will be Docker Hub or if you have the Azure Container Service for that, ACS. We will see that, but you have the ability to deploy your images in a Docker repository in the cloud. Edge starts up and it will see, oh, I have to start up a custom module, stream analytics, functions, cognitive, and machine learning. It downloads those images from the cloud, it spins it up, and of course, probably you've seen that in the talk of Elton. Once you start up a Docker image, you can pass like arguments, like startup things that can be treated as environment variables. So if you say, I'm starting up this stream analytics container, you can say, okay, and you have to execute this job. So that's interesting, where you have all these modules downloaded automatically. And you see modules from Azure services that will be provided on the edge. So stream analytics, that we all know from the cloud side of things, you will be able to execute your stream analytics queries on your device locally. Functions, you will be able to execute it locally. Cognitive services, so think about all the image recognition and text-to-speech and all these things. You will be able to execute that locally. The machine learning thing, actually executing a machine learning model that has been compiled, it's not a hard thing. It's the training of the Azure machine learning thing that takes all the compute and all the machines. So what we will see is that the training of the Azure machine learning models will be done in the cloud, of course, because that's where you need the big compute power. But the execution of your machine learning thing, like, whoa, I feel that this machine will go crazy, that you execute locally. So that's the concept that we see. They are moving services to the edge, and you can execute them there. One of the things that is not clear, and I always give a warning when I talk to customers about this, is you will not get this for free, probably. Microsoft does not want you to suddenly buy your new big terabyte server and execute all your stream analytics and all the Microsoft services locally. So there will probably be a billing model for it. And it might maybe even be different from this one to this one. Nothing is visible, but just take that into the back of your mind. If you take this with customers, you will probably have to pay for that in a consumption-like way. Once you have your edge running, you're still capable from the cloud to say, oh, the stream analytics container, I will change the module twin. So you change it in the cloud using the Azure IoT SDK. You say, oh, the query, instead of taking the average of 5 minutes, I will take the average of 10 minutes. You change the query. The query will automatically be, let's say, evented all the way back to the client side, and the container configuration will be set up, and the thing will be changed. So that's pretty interesting that you have a cloud-managed way of handling all these edge capabilities. You also see this one. That's actually a product that we are making that is a field gateway, so the Nebulous IoT gateway. I just show it here because it allows you as well to have your custom logic, your custom containers executed locally. So if you say, oh, we have a very interesting security module, and we want to execute security principles, or you have that nifty machine learning thing, you will be able to build your module, which is actually making a Docker image, and make it available there so that you can use it in the edge. I'm not sure if Microsoft will do that, but I would love to see another marketplace, I know, but where partners like us can provide their edge modules. If someone has this crazy idea about, oh, I have very good temperature control or whatever, they could make that edge module available and maybe have some billing for that. That would be interesting to see. But I don't know if they have any plans for that one. So just know that Microsoft moves services to the edge because they know that that will be more and more important, that not everything has to be going to the cloud to execute, especially for these critical things. Just for the matter of time, because I'm between you and lunch, I'll show the concept of an edge device not using Azure IoT Edge because that's still NDA, but you will see all these concepts. So just going to this one, as I said, this is the product that we are making, where I'm able to manage devices, and I'm not going to talk too much about the product itself. Just think about these, the concepts. But for example, this is my cloud, where in the future I will be able to deploy things and I can provision things. This is, for example, the SAM Azure demo is the one that I will start up. You can see the status of that one is provisioned. So it's there, but it's not connected at all. In this gateway, so let's say the edge device, I have some configuration. So these could be your modules. I'm saying I have to connect to that device using SNMP. I'm connecting to that device using OPC UA. So you specify all of that. And you say, and once I have data, I will send it to that IoT hub. Not going too much in the details, but you can see the status is provisioned and it has some activation keys and so on. What I also see is that I have modules. So the modules, think about what I showed, the edge modules, those Docker containers. I can specify them there. So I can say, okay, all the Nebulous modules of that version have to be downloaded once the gateway starts up. Okay? So what I will do now, I will just start up that gateway in an interactive manner. And you will see that the gateway, it knows nothing more than its, let's say, call home endpoint. So it has a security to call home, it has an endpoint to call home, and it has, let's say, a device ID. It's not activated, so I'm starting it up. It's not activated, and you will see a lot of technical things. And I will stop it once I'm here. So it says, oh, the gateway has not been activated, I will activate myself. So the gateway does that connectivity with the cloud. The cloud says, hey, yeah, I know you. The next thing he does, he goes and asks for the configuration. Give me my configuration. And the other thing he does is packages. So he downloads those packages from the cloud. So what I'm seeing now, if I do enter again, you can see that everything starts up and so on. And if I go to the portal here and I do an F5, you can see my device is now connected. So it's live connected. If I would stop my device, I do an F5, it's disconnected. Now, the interesting thing is, I'm able, and actually I still have to start something. This thing. So now it's actually not doing anything because all the channels are disabled. But if you have your edge device there and you say, okay, I'm changing the status from disabled to enabled, and I click the update, what happens is that since that device is connected to the cloud, it gets a push. It gets an event that says, hey, this is your new configuration. So it gets that event and it goes and starts and asks everything. And you can see it restarts itself. And now it will send, if everything goes fine, these, I will put a break here. It actually sends the, because that's the configuration, the lux, so the light power, the XYZ of my movement, so the gyrometer that is in my surface here. So it sends that all to the cloud. So you can see that if I'm now moving, you will see that the X, Y, Z things are not 0, but something there. So it sends all that data to the cloud. So I did not have to do anything locally, just the installation, and I managed everything from there. The last thing I want to show is, I think it's here, from the cloud, so in the future on the IoT Hub, I'm capable to say, okay, let's now push a new module. So I'm saying the module 100 of OPC UA, I will push that to the device as well. So let's move, let's go and look here to the, and I will delete the module so that you can see that things happen. I'm updating the configuration, and after a while you will see that this will restart itself because it receives that ping that, hey, there is a new configuration thing. You can see the gateway starts up again, and if I now would move here, you can see that the OPC UA module got downloaded from the cloud again. So what I'm showing here is that the concept of Edge is really all about having local execution, but still having cloud management. So if you have your devices spread out all over the world, you still want to monitor, you want to manage, you want to configure everything from a central place. And that's what Azure IoT Edge will give you. So the thing I showed here is not Azure IoT Edge, but you will see these same concepts coming back in Azure IoT Edge specifically. I hope things were clear. That was actually the last thing I wanted to show. I would say thank you, but I'm definitely open for questions. We have one question there. And of course, during lunch, after lunch this afternoon, don't hesitate to contact me.
This particular scenario, is it over-the-air update kind of thing? And how is it different from connected devices that we have in schools that directly communicate?
So the question was, how is this different from having connected devices that have, let's say, a direct link? What is different here is that the devices that we have to talk with Azure IoT Edge, for example, they don't have to have an internet connection itself. So as I said in the beginning, direct connectivity in devices is definitely valuable, and you will always see that in the domestic, in the private use. In the industry, we see that edge capabilities are much more, executed outside of the device. So you have the device layer, and then you have all those other layers like Profinet, SCADA, and all of that, and then you see the edge. So the edge is playing just before the cloud. So what I did not actually say is that all those modules, they talk to each other. So you have actually a microservices, if you want, architecture locally, close to your device. And these modules talk to each other by configuration. So you can say, if my message has been picked up from that device, I will now execute this stream analytics query, and then I will execute the machine learning thing. And it's all disconnected and not in the device itself. So you have one edge computer, typically, maybe for 20 devices. And you have the ability to aggregate events from devices, for example, in one central place. So maybe I did not make that clear enough, but I hope that answers the question at least. Okay? Anything else?
Are there any minimum hardware requirements for running Edge, kind of local, can I use an ARM processor?
Yeah, so the question is, what are the minimum hardware requirements? There was a slide that talked about 128 megabyte RAM. As far as I know, it will run on ARM. It will run on x86, x64. Raspberry Pi, yeah, definitely. I think that's 2 gigabytes or something. And okay, but yes. Of course, I'm not sure if you will be able to have good quality cognitive services locally executed. So it will always still depend on what you do, what you use on that edge. If you just use it to connect and stream it to the cloud, that will be fine. So the edge runtime itself is minimal. But if you download all these Docker containers and they require themselves more, you might have limitations there. Okay? What? I don't mind.
Are you limited to having one edge device between the devices and the cloud, or can you separate it into having devices, edge device, cloud?
I don't see a reason why. There's no limitation, but just know that every edge device will have internet connectivity. So you could have one edge device talking to another edge device, but that would be using a protocol outside of the edge container. So let's say it's not something they need natively, or they are considering natively, as far as I see. Does it make sense? Okay.
No, yeah, my question is around legacy to moving into using an IoT hub. So let's say I have a service that is already collecting data from my devices. It's running locally,
question is, what if I have some local logic and it's not yet IoT Hub enabled? How do I get it into IoT Hub for existing or legacy devices? You just use the IoT Hub SDK if you want to have a direct connectivity there. The SDK that fits your needs. So they have a lot of them. So C, whatever you need. Or you can say, oh, but I have an existing interface like in industry with OPC UA, and then you could say, I'm using an edge device that, connects locally and takes the IoT Hub connections themselves. Because adding that thing is just a matter of 5 lines of code for your proof of concept. If you want to get it really, rock solid with all the retries and all these things, then you will end up with more complexity. And that's why we feel that a gateway sometimes, especially for legacy devices, can be interesting. Okay? Last question, or?
Often the examples are like one sensor that's sending data, but in our case we have the more complex machines that have
Yeah.
configuration type. Do you have any comments on that, on the architecture, really?
Yeah, so the thing is, in maybe industry mostly has a complex topology where you have sensors are inside a machine, a machine is part of a production line, for example, so you have like a hierarchy of devices and things and so on.
Configuration
Yeah.
business logic already in the machine that's there. It makes evaluation and aggregates itself.
So what about getting that data indeed bubbled up and sometimes you do aggregation on different levels? That's indeed very common that on the lower level you have sub-millisecond execution and decisions, and you have some aggregated data that bubbles up all the way into the edge probably, where then it gets sent into the cloud. So it's very common where you have indeed the edge talking to, for example, the PLC or a system that is like SCADA and so on, where it's not having to be involved direct with the with the sensors, for example.
The protocol used between the local edge gateway and the IoT hub can handle more complex structures than just.
No, the question is what with the protocol between IoT Hub and the cloud? That will always be AMQP, MQTT, HTTP.
I mean the data structure within.
The data structure. That's, as I say, it's opaque or opaque. I don't know how you pronounce it, but the IoT Hub doesn't care on your data logic. It's you can send whatever you want as long as you have that maximum size respected. And in the cloud backend, there you do your processing. So we have customers that define their data models and have indeed quite a complex JSON structure, and they compress it even before they send it into IoT Hub and so on. So that's really up to you and the configuration locally.
So it's not part of the standardization?
No. That's a good question. Standardization on device models and data design for IoT Hub is really something that we could use. I know OPC UA is doing efforts there, but there's no like global standard as far as I know. I think we have to close down. Thanks for the time, and I'm here all day.
We'll have
So
lunch, and in 30 minutes, thank you. Lunch, 30 minutes.